So one of the exciting things that's happening now is that with ever increasing computer power, we can create larger, more complex computer models and ones that will say have higher spatial resolution. In other words, smaller grid boxes. We take the globe, the atmosphere, and the ocean, 3 dimensions, and divide it up into millions of grid boxes. And the smaller those grid boxes can be, the more realistic the simulation. In much the same way you might prefer to watch a television show on high-def TV than you would on a grainy YouTube video, or I'm not quite sure what the quality of this Skype interview is, but it's probably not at the standard of really high-def TV. In that same way, the smaller we make the grid boxes, the more detailed, the better the model has the chance of representing some of those key processes and the different interactions between the parts of the climate system so that we can get a more realistic view of how things go. So it's a linkage between computer technology and the science of climate. So it's not just about aesthetics either. It's not just that the picture is clear. We're actually being able to more accurately represent some of the processes that are going on in the system. For example, when I first got into this field a number of years ago, our computer models had much bigger boxes. It's all that the computer architectures of the time could support. As a result, in the ocean, the Gulf Stream, well, the models produced the Gulf Stream. It moved to the Atlantic Ocean, but it was fairly broad and kind of diffuse, I think you would say. In today's models, we can create cases where those grid boxes are small enough, and we get such resolution that we now can see this sharp Gulf Stream that looks much more like what we would see in observations, much more like satellites show us, producing eddies and whirls and different features that help transport heat, nutrients in the ocean and others, and we just get a more realistic view of the world. We can even go to the point where it's these interactions that are pretty interesting as well. For example, we can now run computer models where we're not plugging in any numbers or answers. We essentially tell the model where there's ocean, where there's land, how deep it is, how high the mountains are, and we turn on the sun. And this computer model, based upon the physics inside it, will produce its own tropical storms. And as those tropical storms move across the ocean, they mix up cooler waters from beneath. And we can see all this simulated in our model without actually plugging in those kinds of things. So it's a really interesting. We're moving the science forward, and it's that combination of advancements in the scientific knowledge and the computer technology that are giving us this ability to take it to the next step.